Welcome to Sleep with Science. This evening, we'll explore an overlooked realm that exists all around us, the fascinating world of fungi. These organisms aren't plants, nor are they animals, but occupy their own unique domain. Like us, they inhale oxygen. They expand quietly through their environments, and they've influenced our planet's ecosystems longer than woodlands have existed. Certain species emit luminescence in darkness, like scattered lamps throughout the evening. Others extend vast and hidden below our footsteps, linking tree roots in a concealed network. Some display pigments so vibrant they appear hand-painted, while others possess toxins so potent that a mere morsel could prove fatal. Yet fungi also serve as physicians, constructors, decomposers, and visionaries. They cause dough to expand. They ferment juice into spirits. They possess the ability to purify environments contaminated with petroleum and synthetics. And they could even assist us in conceptualizing how existence might continue on distant worlds. Should you appreciate these scientific journeys, please consider subscribing or leaving feedback in the discussion section. This enables others to discover this space, one restful listener at a time. For now, though, let us commence. Fungi share closer kinship with animals than vegetation. Most individuals find it surprising that fungi, despite existing peacefully in woodlands and emerging from earth like blossoms, actually possess more genetic similarity to humans than to vegetation. On a molecular level, these organisms share an ancestral line with fauna, not flora. They consume oxygen and release carbon dioxide precisely as we do. Their cellular boundaries aren't constructed from cellulose like vegetation, but from chitin, the identical resilient substance composing the exoskeletons of arthropods and shellfish. This peculiar relationship positions fungi within an obscure taxonomic branch we seldom contemplate. While traversing a woodland, it might appear that fungi belong among the foliage and petals, but actually, their nearest relatives are beings that ambulate, navigate water, and take flight. Understanding that a fungus shares, in essence, greater similarity to us than to a strand of vegetation can transform how you perceive the woodland substrate permanently. Certain fungi emit their own organic illumination. Picture walking during evening through woodland where miniature beacons scatter through the vegetation. Fungi radiating gently, emerald or azure, resembling fairy illumination woven through the terrain. This radiance is termed bioluminescence, the identical phenomenon that lightning bugs and certain oceanic species generate. Over 70 identified fungal varieties can produce this effect, including the appropriately designated foxfire species. Researchers theorize the radiance might draw nocturnal insects, assisting the fungi in distributing their reproductive particles more extensively. Or potentially, it merely safeguards them from consumption. The luminescence originates from a biochemical process involving an enzyme termed luciferase, the identical reaction family that provides lightning bugs their sparkle. Witnessing one of these fungi in their natural habitat is experiencing primordial enchantment, organic radiance emerging from decomposition, evidence that even as timber deteriorates in fragments, magnificence can still emanate through the shadows. An individual fungal system can span miles beneath the surface. Below your position concealed within the substrate, there might be an organic network so extensive that it extends for miles. Fungi are merely the reproductive structures, the apparent portions of a considerably larger entity called mycelium. Mycelium consists of delicate thread-like structures that interweave through the ground, encircling roots, minerals, and even decomposing foliage. In certain locations, this system is incomprehensibly vast. An individual mycelial entity can traverse across elevations and depressions, connecting countless trees collectively. Envision a mesh composed of existence, undetectable yet animate, quietly functioning beneath the woodland substrate. Via these systems, fungi recycle minerals, transport moisture, and even enable vegetation to exchange materials with each other. It appears as though the planet itself possesses circulatory vessels coursing with concealed filaments. Walking across a meadow might mean stepping inadvertently upon a single enormous creature, primordial, tranquil, and omnipresent. Earth's most massive living entity is a fungus. Within the Blue Mountains of Oregon exists something remarkable. Initially, it resembles typical woodland conifers, waterways, and grasslands. Yet concealed beneath the substrate lies the most massive living entity, documented on our planet, an individual fungal system of Armillaria solidites, frequently termed the honey fungus. This enormous mycelium extends across approximately 4 square miles and is estimated to be millennia old. Each fungus you observe, emerging from the substrate, there is merely 1-minute fragment of this tremendous organism. For perspective, this single entity surpasses the most massive blue whale numerous times over and has existed quietly longer than numerous human societies. Upon scientists' discovery of its actual dimensions, they understood that the woodland they were traversing was not composed of innumerable separate organisms, but of one immense being, extensive and ancient, flourishing below their footsteps like the planet's very heartbeat. Fungi can transmit information using electrical impulses. Despite lacking brains or neural systems, they dispatch information pulses through their mycelial filaments. These impulses resemble minute electrical signals, comparable to neuron activation in fauna. Certain researchers have discovered that these pulse sequences even somewhat resemble linguistic patterns with frequency variations potentially conveying significance. Through this mechanism, fungi might communicate information regarding threats, materials, or environmental factors with different sections of their system. It appears as though a subterranean information network is interwoven within the substrate, conveying impulses in a dialect we're merely starting to comprehend. Envision trees transmitting carbohydrates to each other, with fungi serving as the messengers relaying the information. Though it might not constitute cognition in the manner humans comprehend it, it represents communication nonetheless. Evidence that consciousness manifests in numerous forms, and the planet resonates with dialogues we cannot perceive. Certain varieties can endure in outer space. Upon scientists' examination of what existence could withstand beyond our planet, they transported fungal spores along. To their astonishment, certain varieties not merely endured exposure to spatial vacuum, but also withstood extreme radiation and sub-zero conditions. The reproductive particles floated beyond spacecraft for weeks, protected solely by their inherent resilience. Upon return to our planet, numerous remained viable and capable of development. This durability renders fungi intriguing prospects for astrobiology, the examination of existence beyond Earth. If fungal spores can endure the emptiness, it suggests the likelihood that existence could traverse between worlds, traveling on meteoroids or particulates across the universe. The concept is termed panspermia, and fungi constitute evidence that such voyages might not be unfeasible. Consider the modest fungus, frequently disregarded in the woodland, transporting the essence of existence across star systems, awaiting to flourish again wherever it encounters substrate, moisture, and illumination. Fungi have been discovered developing within nuclear facilities. Following the Chernobyl catastrophe in 1986, researchers examining the devastated reactor were astounded to discover something prospering amid the devastation. Fungi, particular varieties, including Cryptococcus neoformans, not merely endured within the radioactive destruction, but appeared to develop toward radiation itself. These fungi possess melanin, the identical pigment present in human epidermis, which might enable them to transform radiation into biochemical power, somewhat like photosynthesis utilizing radiation rather than illumination. It appears as though these fungi are consuming radiation, converting what we perceive as lethal into energy for development. This revelation has enormous consequences for tomorrow. Eventually, fungi might assist in purifying nuclear contamination or safeguard space travelers from cosmic radiation during extended space voyages. Within the most shadowy, most hazardous locations on our planet, fungi have discovered a method to exist and potentially even to flourish. Fungi possess the ability to decompose synthetic materials and petroleum. Among the most promising revelations in recent times is that certain fungi serve as organic recyclers on an immense magnitude. Particular varieties can degrade substances that typically endure for ages, including synthetic polymers and petroleum products. In 2011, investigators discovered a fungus within the Amazon rainforest capable of consuming polyurethane, among the most persistent synthetics in production. Additional fungi have demonstrated the capacity to degrade petroleum contamination, converting harmful substances into benign material. Envision waste repositories diminishing not through human machinery, but through quiet fungal populations consuming steadily. Researchers are currently investigating how these fungi could assist us address contamination, potentially eventually engineering fungal biofactories that could consume synthetic refuse. In a society overwhelmed with our discarded materials, fungi remind us that the natural world frequently possesses the mechanisms to restore itself, if only we possess sufficient wisdom to observe and comprehend them. Certain fungi can terminate you with a single morsel. Among the numerous marvels of fungi, danger also exists. Certain varieties possess compounds so potent that even a minor amount can prove fatal. The death-cap mushroom Amanita phalloides is among the most lethal. Its poisons quietly devastate the hepatic and renal systems, and manifestations might not surface until too late. What renders it even more disturbing is how unremarkable it appears. A pale verdant fungus that could be confused for something consumable. Across history, lethal fungi have terminated the lives of monarchs, commoners, and even entire households who are unaware of the danger. The boundary between sustenance and toxin in the fungal realm is razor-thin and frequently imperceptible. Yet within this danger exists intrigue. How a delicate-appearing fungus can contain sufficient chemistry to terminate a human existence reminds us that nature, though magnificent, must always receive respect. Others possess flavors almost precisely like shellfish or poultry. Not all fungi present danger. Certain bring pleasure. Particular varieties possess flavors so remarkable that they replicate flesh or seafood almost flawlessly. The lobster mushroom, for instance, possesses a vivid crimson-orange pigmentation and a flavor that evokes the delicacy of crustaceans. Chicken of the forest, with its stratified fan-like configuration, separates into portions that resemble poultry flesh, both in consistency and flavor. For ages, foragers have valued these fungi as organic substitutes to flesh long before plant-based nutrition became widespread. To consume one is to encounter the peculiar adaptability of fungi, how something developing quietly from tree bark can taste like a banquet from the ocean or the pasture. It appears as if fungi are transformation artists of flavor, adopting tastes from the fauna realm while remaining solidly within their own enigmatic domain. Prehistoric societies utilized fungi in holy ceremonies. For millennia, fungi have occupied a position not merely in culinary spaces, but also within sanctuaries and rituals. Populations perceived something mystical in how fungi appeared to manifest overnight as if summoned from nowhere. In Siberia, spiritual leaders utilized the red and white Amanita muscaria, the legendary storybook mushroom, in ceremonies to achieve trance conditions. In Mesoamerica, the Aztecs referred to sacred fungi as teonanacatl, signifying the substance of the deities, and they utilized them in rituals to commune with the transcendent. Even prehistoric cave art in Spain, estimated to be over 6,000 years ancient, depicts individuals holding fungi. These organisms weren't merely sustenance. They were passageways to modified conditions, revelations, and spiritual voyages. To our forebears, fungi appeared like communications from another dimension, emerging mysteriously from the ground to remind humans of the delicate boundary between the mundane and the exceptional. Certain fungi assume control of insect cognition. Among the most unsettling and captivating occurrences in the natural world is generated by fungi designated as cordyceps. These fungi don't merely develop peacefully in substrate. They contaminate insects, seizing control of their actual conduct. A reproductive particle contacts an ant, and quickly the fungus commences spreading within its form. Subsequently, it influences the ant's cognition, compelling it to ascend a stalk or vegetation to the optimal elevation for spore dissemination. There, the ant grasps motionlessly, as if suspended. Subsequently, the fungus erupts through its form, developing a peculiar stalk that discharges spores to contaminate others beneath. This disturbing sequence has earned cordyceps the designation zombie fungus. Though unsettling, it also exemplifies how fungi have developed sophisticated, if disconcerting, tactics to endure. The woodland substrate conceals entire scenarios where even insects can become involuntary performers in the fungus's quiet performance. A fungus previously eliminated entire communities of amphibians. During the late 20th century, scientists started observing frogs, salamanders, and toads vanishing worldwide. The responsible agent proved to be a fungus termed Batrachococcaeotrium dendrobatidis, or BD briefly. This fungus contaminates the epidermis of amphibians, interrupting their capacity to respire and maintain hydration. Since amphibians acquire considerable oxygen and hydration through their epidermis, the contamination frequently proves lethal. Entire communities disappeared apparently instantly, and the fungus has been termed among the most catastrophic pathogens in documented history. To realize that something so minute, invisible to casual observation, could restructure entire ecosystems demonstrates the concealed power of fungi. Even presently, preservationists are working to safeguard susceptible varieties, creating antifungal interventions and cultivation initiatives. The narrative of BD is a cautionary reminder. Fungi are not merely assistants and recyclers, but occasionally annihilators, modifying the trajectory of existence on our planet. The atmosphere you inhale is abundant with fungal spores. Each inhalation you take transports with it minute fragments of the fungal realm. Fungal spores, the microscopic reproductive units of fungi, are so plentiful that billions drift invisibly through the atmosphere surrounding us constantly. They traverse through urban areas, woodlands, and seas, descending with precipitation or drifting for miles on air currents. Researchers calculate that each cubic meter of exterior atmosphere can possess thousands of spores. You consume them without ever recognizing. Yet your physiology is adapted to this concealed domain of existence. In actuality, spores constitute among the most prevalent biological particulates in our planet's atmosphere. They are so minute and weightless that they can even travel air currents upward into precipitation systems. In essence, every inhalation connects you to woodlands and fungi distant, linking your respiratory system to ecosystems you might never encounter. You are perpetually inhaling the quiet existence of fungi. Spores are so weightless they can drift in the upper atmosphere. Unlike seeds, which are frequently heavy and confined to substrate, spores are engineered to journey. Numerous are so minute and weightless that they can remain suspended for remarkable durations of time. Certain have been identified more than 20 kilometers above our planet's surface, drifting in the stratosphere. There they might catch transport on elevated altitude air currents, traversing across seas and land masses. Spores are furnished with defensive coverings that protect them from solar radiation, aridity, and even radiation, enabling them to endure such voyages. This capacity to journey immense Distances renders fungi among the most accomplished colonizers in the natural world. Envision a single spore discharged from a puffball fungus in a grassland, ascending into the atmosphere, and months subsequently settling into substrate on the opposite side of the world. Spores transform the atmosphere itself into a corridor for existence, invisible yet continuous, linking ecosystems worldwide. Certain spores can endure a voyage through outer space. In trials where spores were subjected to the vacuum and radiation of outer space, numerous succeeded in surviving conditions that would eliminate most organisms immediately. Secured within their resilient protective shells, spores endured not merely for moments, but occasionally for weeks, drifting beyond spacecraft or fastened to satellites. This durability has stimulated the concept of panspermia, that existence could disperse between worlds via spores or microorganisms transported on space rocks or particles. If fungal spores can endure such voyages, it indicates that existence might be more transportable than we previously believed, potentially journeying across the planetary system or even the cosmos. Upon observing a fungus discharging a plume of spores, you are observing a survival mechanism so efficient that it might reach beyond our planet itself. They are minute explorers, resilient enough to withstand the void, awaiting a new planet to inhabit. Fungi can decompose mineral over time. We frequently consider stone as permanent, but even geological formations are susceptible to the gradual persistence of fungi. Certain varieties of lichen, a collaboration between fungi and algae, discharge acids that can decompose minerals, progressively wearing stone into substrate. Across centuries, this mechanism converts mountains, precipices, and geological formations into productive ground where vegetation can develop. Without fungi and lichens, the planet might remain secured in exposed stone, incapable of supporting verdant woodlands and meadows. In essence, fungi are our planet's primordial gardeners, establishing the foundation for all the verdant existence that succeeded. Even presently, on ancient grave markers or historic structures, you might discover small fungal colonies gradually etching designs into the stone. With patience measured in ages rather than moments, fungi quietly reshape the solid framework of our world, demonstrating that nothing exists beyond the scope of their persistence. Particular fungi generate fairy circles in grasslands. Enter a grassy terrain after precipitation, and you might discover a ring of fungi perfectly circular, as if left behind by mystical beings dancing. These are termed fairy rings, and they develop as an individual fungus disperses radially in all orientations beneath the surface. The fungi you observe are merely the portions of the progressing boundary of the mycelium. Across time, the ring expands, occasionally enlarging each season. In mythology, fairy rings were believed to be enchanted locations, entrances to another dimension, or traces of nocturnal dances by invisible entities. Researchers understand now that the rings are merely the organic development of fungi, but the sense of amazement persists. To observe a fairy ring is to observe mathematical patterns alive in the vegetation, a living circle, traced by filaments you cannot perceive, linking the typical grassland with something eternal, concealed, and magical. Certain fungi can manifest overnight following precipitation. There exists something remarkable about the suddenness of fungi. One moment the terrain appears bare, and the subsequent morning it appears dotted with new existence. Fungi can expand remarkably rapidly, occasionally pushing upward through substrate or leaf debris in mere moments. Their development is powered by the concealed mycelium, which accumulates energy until circumstances are precisely correct. Precipitation moistens the terrain and supplies the hydration required, and then the fungus surges skyward, expanding like a time-accelerated marvel. This abrupt manifestation has provided fungi a mystical reputation in mythology, as if they are summoned by spirits or enchantment. In reality, It is biology at its most productive years of invisible preparation culminating in one spectacular emergence. The subsequent time you observe fungi following a tempest, recall that they were already present, waiting patiently for the indication to ascend into the illumination. Fungi have been utilized as organic pigments for textiles. Long before synthetic pigments, populations discovered that fungi could pigment fabrics with surprising intensity. Various varieties can generate shades of amber, emerald, violet, crimson, and even profound azures. Certain dyers still gather mushrooms like Pheolus, designated as the dyer's polypore, which can generate abundant yellow and tangerine tones. Others utilize lichens for subtle rose and violet hues. Each fungal variety possesses unique substances that, when boiled with wool or silk, discharge pigments that adhere to the threads. These pigments are organic, sustainable, and frequently generate pigments that transform subtly in the illumination. Adorning fungal-dyed garments once signified carrying a fragment of the woodland with you, its shades woven into textile. Even presently, craftspeople revive this custom, honoring fungi not merely as sustenance or remedy, but as artists of pigmentation, decorating our world with palettes concealed in the substrate. Certain fungi can ensnare nematodes to consume them. Fungi are frequently considered quiet decomposers, fragmenting timber and leaf debris, but certain are predators. Particular substrate-dwelling fungi have developed methods to ensnare and consume. Nematodes mimic thread-like organisms that wriggle invisibly through the earth. These fungi construct microscopic traps-adhesive meshes that capture passing organisms, or even sophisticated lasso-configured loops that constrict like nooses when contacted. Once captured, the fungus penetrates the nematode and extracts its nutrients, powering its expansion. To conceive of a fungus behaving like a hunter, constructing invisible snares in the substrate transforms how we envision them. They are not inactive entities, but clever survivors capable of predation without vision or locomotion. Beneath your position, there might be entire conflicts of fungi and organisms, invisible but persistent, with each triumph nourishing the gradual, patient expansion of the fungal domain. Fungi can be more resilient than steel in composition. Though fungi appear fragile, their architecture can be astonishingly resilient. The delicate filaments of mycelium interweave into a concentrated interlocking system that rivals certain of the most resilient substances available. Actually, experiments have demonstrated that particular mycelium composites can be more resilient than steel when assessed by mass. This resilience, combined with their weightlessness and biodegradability, has rendered fungi a focus of material research. Engineers are currently experimenting with fungal-based construction substances, bricks, insulation, even furnishings that are resilient, flame-resistant, and fully compostable when no longer required. It's remarkable that what appears like a delicate toadstool in the woodland can inspire construction sturdy enough to sustain dwellings. Fungi remind us that durability is not always prominent or apparent. Occasionally, it is woven quietly, strand by strand, into systems that are modest in appearance, but remarkable in resilience. Fungi were among the initial entities on terrestrial surfaces. Long before vegetation extended toward the atmosphere or blossoms opened their petals, fungi had already emerged onto the shores of primordial Earth. Fossil evidence demonstrates that fungi established themselves on land over 1 billion years previously, assisting to fragment stone into substrate. In accomplishing this, they established the planet for vegetation to succeed. Certain researchers theorize enormous fungal structures once scattered the terrain hundreds of millions of years previously, reaching over 20 feet elevated. These peculiar organisms, termed prototaxites, might have been the most elevated living entities of their epoch. Envision a desolate alien terrain where colossal fungal pillars ascended above the terrain long before woodlands or grasslands existed. Without fungi to establish the foundation, a planet as we comprehend it fertile, verdant, and alive with vegetation might never have manifested. They were the quiet pioneers of terrestrial existence, forming the planet with patience and persistence. Certain fungi are so minute they balance on a pin's point. When most of us envision fungi, we consider caps substantial enough to gather, prepare, or capture in a woodland. But in the concealed microrealm, certain fungi are so minute they can rest easily on the point of a pin. These miniature fungi emerge like particles of powder on decomposing foliage or fallen branches, frequently visible solely under magnification. Despite their dimensions, they still execute the identical essential function as larger fungi fragmenting matter and discharging spores. Numerous of these microfungi generate delicate, almost crystalline configurations with caps no larger than particles of sugar. To envision that such delicate, transient life forms exist surrounding us, invisible, is humbling. The woodland is not merely filled with towering vegetation and substantial fungi, but also with minute realms of existence that flourish in spaces too small for our vision to detect. Others can expand to be larger than a human. At the contrary extreme, certain fungi expand to remarkable dimensions. The giant puffball fungus, for instance, can expand to the dimensions of a beach sphere, with certain specimens weighing exceeding 20 pounds. When matured, a single puffball can discharge trillions of spores in a smoky plume that travels on the air current. In tropical woodlands, the enormous bracket fungi attach to tree trunks. Like platforms, certain expanding wide enough to function as an organic seat. In mythology, these colossal fungi inspired reverence, as they appeared less like vegetation and more like beings of legend. To position before one of these enormous fungi is to be reminded that fungi are not always minute or transient. They can be monumental, extensive, and persistent, their dimensions rivaling that of the beings that ambulate among them. A realm of extremes fungi extend from the nearly imperceptible to the astonishingly immense. The fragrance of truffles can drive fauna frenzied. Truffles, the valued subterranean fungi, discharge an aroma so potent it mesmerizes both humans and fauna. Their fragrance possesses substances similar to pheromones, the biochemical signals numerous beings utilize for interaction. For swine particularly, the fragrance of truffles can be compelling, so considerably that cultivators previously depended on swine to locate them. Canines are presently favored as they can identify the fragrance without consuming the discovery. Humans equally are captivated. Truffles constitute among the most costly foods globally valued for their earthy, musky, intoxicating fragrance. The aroma drifts through substrate, attracting fauna that excavate them up, inadvertently assisting disperse the spores. This peculiar tactic has enabled truffles to prosper subterranean, where they cannot discharge spores into the atmosphere. Instead, they depend on an attraction, a perfume so compelling that entire varieties are compelled to pursue them out. Fungi assist trees communicate with each other. Profound in the woodland, trees are not quiet. They exchange carbohydrates, moisture, and even alert signals with each other, and fungi render it feasible. Mycorrhizal fungi establish collaborations with tree roots, extending their mycelial systems deep into the substrate. Through these links, trees can distribute materials. A shaded tree, for instance, might obtain additional carbohydrates from its sun-exposed neighbors conveyed along by the fungal filaments. If parasites or ailment menace, biochemical signals can disperse subterranean, warning other trees to establish defenses. This concealed dialogue is occasionally termed the wood-wide network. Without fungi, woodlands would be considerably less collaborative, and numerous young trees would never endure. The subsequent time you traverse through a woodland, envision the roots below you not as separate mechanisms, but as components of a great, interconnected consciousness, a quiet system where fungi serve as the interpreters between titans. The wood-wide network links entire woodlands. The concept of the wood-wide network has captured the fascination of researchers and narrators alike. It is not merely individual trees that link through fungi, but entire woodlands. A single mycelial system might connect dozens, even hundreds of trees, binding them into one interdependent society. Ancient mother trees can nourish their offspring through this network, nurturing the subsequent generation. Dying trees can even transfer their remaining materials, leaving behind a form of inheritance through the system. This subterranean network enables a woodland to function less like an assemblage of individuals and more like a single entity, responsive and animate. What we observe above terrain trunks, branches, and foliage is merely half the narrative. Below, in the shadowy substrate, the fungal realm is constructing a network as intricate as the neural systems in our own cognition, maintaining the woodland's concealed cohesion. Fungi can accumulate carbon subterranean for ages. Among the most quiet but most significant roles fungi execute is in carbon accumulation. Through their collaborations with vegetation, fungi assist transport carbon from the atmosphere into the substrate, securing it away in subterranean systems of mycelium. Certain of this carbon can remain interred for ages, safely accumulated out of the atmosphere. In this manner, fungi are confederates in stabilizing our planet's climate, preventing surplus carbon dioxide from warming the world too rapidly. Woodlands owe considerable of their role as carbon repositories to the fungal networks that maintain nutrients flowing in carbon accumulated. Even when fungi decompose material, they regulate how rapidly carbon is discharged back into the atmosphere. In a period when climate modification dominates human anxiety, the modest fungus might prove to be among Earth's most effective protectors, functioning quietly beneath the substrate to maintain equilibrium in the planetary cycle. Certain fungi develop only on fauna excrement. As peculiar as it sounds, particular fungi flourish in locations most of us would evade the excrement of fauna. Varieties like Copernopsis, occasionally termed inky caps, emerge directly from manure. This might appear unappealing, but it's a sophisticated tactic. Excrement is abundant in minerals already fragmented by the fauna's digestive mechanism, and fungi are perfectly equipped to recycle what persists. In accomplishing this, they complete the cycle of existence, converting refuse into productive substrate once again. Certain of these fungi even propel their spores with remarkable force, projecting them sufficiently distant to escape the shadow of the excrement pile and contact fresh vegetation where grazing fauna might consume them, commencing the cycle anew. What appears unpleasant to us is to fungi opportunity. In their realm, nothing is squandered, not even the most improbable substances of existence. Others manifest only following a woodland conflagration. Certain fungi await patiently for devastation before making their appearance. These are designated as pyrophilous fungi, admirers of flame. They remain concealed in the substrate until flames traverse through a woodland, eliminating vegetation and leaving behind ash. Then, almost miraculously, fungi like the morel commence to emerge in great quantities. Flame modifies the chemistry of the substrate, generating circumstances that these fungi necessitate to flourish. The ravaged woodlands can become repositories of morels, valued for their honeycomb caps and abundant earthy flavor. But beyond human intrigue, these fire-following fungi execute a vital ecological function. They recycle minerals rapidly, establishing the terrain for new development and assisting woodlands recover from devastation. Where flames have consumed, fungi ascend, converting loss into the commencement of restoration. In their quiet manner, they are the initial responders of the woodland, converting devastation into productive terrain for rebirth. Particular fungi possess organic antimicrobials. Long before contemporary medicine, fungi were already biochemists generating substances to protect themselves against bacteria, and other microorganisms. Numerous of these substances prove to be beneficial for humans as well. Penicillin, the initial widely utilized antimicrobial, was famously identified in a mold, a close fungal relative of mushrooms. But fungi themselves possess antimicrobial compounds, also certain of which are being examined as potential interventions for contaminations. In the natural environment, these substances assist fungi endure in environments abundant with competitors. For us, they are reminders that solutions to human challenges frequently exist quietly in the natural world, awaiting to be recognized. The subsequent time you observe a fungus developing from a fallen log, envision it as a minute laboratory, crafting biochemicals not merely for its own endurance, but potentially for the restoration of beings far beyond its woodland habitat. Without fungi, bread and beer wouldn't exist. The everyday miracle of bread ascending in the oven or beer foaming in a glass is rendered feasible by fungi. Yeast, a single-celled relative of mushrooms, converts carbohydrates into ethanol and carbon dioxide. This mechanism not merely provides bread its fluffy consistency, but also generates the bubbles in beer and champagne. Without fungi, human cuisine would appear entirely different. No loaves of warm bread, no wine, no frothy ales. Archaeologists have discovered evidence of fermentation extending back millennia, demonstrating that humans and fungi have been collaborators since the dawn of civilization. In essence, fungi have influenced culture as considerably as they have influenced woodlands, affecting ceremonies, economies, and festivities. When you separate open a loaf of bread or consume a beverage, you are tasting the invisible function of fungi harnessed for pleasure and sustenance since time immemorial. The yeast utilized in bacon is a fungus. It's easy to forget that the yeast distributed into dough or combined into a brewer's vessel is animate. These microscopic fungi consume sugar, multiplying rapidly and discharging gases that expand dough or generate fizz. Though minute, yeast are primordial companions of humanity. They were likely initially discovered by chance when wild yeast drifting in the atmosphere contacted crushed fruit or moist grains, initiating fermentation. Across time, populations learned to cultivate and regulate yeast, converting them into the invisible laborers behind culinary spaces and breweries. Contemporary yeast strains are carefully cultivated, but they remain members of the fungal realm, relatives of the mushrooms that emerge in woodlands. In every loaf of bread, every bottle of wine, there exists a quiet fungal narrative, billions of cells functioning collectively, invisible but essential, converting sweetness into substance and reminding us of existence's concealed connections. Certain fungi can discharge crimson liquid. In particular woodlands, you might encounter a fungus that appears as though it has been injured. Droplets of vivid crimson liquid accumulate on its cap, resembling blood. Among the most famous is Hydnellum pecki, occasionally termed the bleeding tooth fungus. Despite its disconcerting appearance, the crimson fluid is not blood, but a sap-like exudate abundant in pigments and substances. The purpose is still disputed. It might assist the fungus regulate hydration or repel microorganisms. To encounter such a fungus feels peculiar, as though the natural world is replicating the familiar in peculiar and unsettling manners. These bleeding fungi remind us that the woodland contains secrets engineered not for human observation, but for the endurance of the entities themselves. We are merely incidental witnesses traversing through a realm where even fungi can discharge crimson jewels in the vegetation. Others emit fragrances precisely like decomposing tissue. Certain fungi endure not by appearing magnificent, but by emitting revolting odors. Designated as stinkhorns, these fungi discharge fragrance nearly identical to decaying flesh. The odor attracts flies and beetles, which contact the fungus and inadvertently transport away its spores. It is a sophisticated tactic, converting revulsion into dissemination. To humans, the odor can be overpowering. Yet these fungi are masters of deception, misleading insects into executing their purposes. In certain cultures, stink horns are connected with spirits or portents, their abrupt manifestation and foul fragrance linked to superstition. But in actuality, they are merely clever survivors developing to utilize fragrance as bait. In the quietness of a woodland, the abrupt scent of decomposition might not indicate mortality at all, but rather the peculiar existence of a fungus executing tricks on the senses of every being that traverses. Fungi can generate entire subterranean metropolises. When mycelium disperses beneath the substrate, it doesn't merely form random filaments. It constructs intricate layered systems that resemble thriving subterranean cities. Corridors of hyphae branch and reconnect, generating channels for minerals to flow. Certain areas function like exchanges, where materials are traded with vegetation. Others function as storage chambers containing reserves for sparse periods. Researchers utilizing advanced imaging have discovered that these systems display remarkable productivity, optimizing routes comparable to human-engineered infrastructure. In essence, fungi are architects constructing concealed architectures that rival our own settlements in structure. While we establish roads and construct towers above terrain, the fungal realm is quietly constructing intricate realms below, where billions of entities collaborate and prosper. The substrate beneath our position is not vacant, but animate with a society of filaments, a metropolis without boundaries, radiating gently with the rhythm of existence. Certain fungi can modify pigmentation when contacted. In the fungal realm, appearances can be misleading. Certain fungi transform their pigments when manipulated, bruised, or severed. One striking instance is the blue-staining bolete, which transforms a vivid cobalt azure when its tissue is subjected to atmosphere. This pigmentation modification occurs because of biochemical reactions between substances in the fungus and oxygen. For foragers, the conversion can be a beneficial identification indicator. Though not consistently an indicator of edibility, the phenomenon is captivating. A plain-appearing fungus instantly converts into something dazzling as though exposing a concealed aspect of itself. In mythology, fungi that modified pigmentation were believed to be enchanted or mystical, possessing secret capabilities. To contact one presently is to experience that identical amazement that in the simple gesture of interaction, the woodland exposes a deception, a transient glimpse of chemistry disguised as sorcery. There are fungi that emit fragrances like maple syrup. Not all fungal fragrances are disagreeable. Certain discharge perfumes so delightful they appear engineered for human appreciation. The candy cap mushroom, for instance, possesses a fragrance almost identical to maple syrup. When dehydrated, the aroma intensifies, saturating spaces with the sweetness of pancakes and sugar. Culinary experts utilize these fungi to flavor desserts, pastries, and frozen treats, converting a woodland discovery into culinary enchantment. The fragrance originates from substances termed lactones, which deceive our senses into connecting the fungus with sweetness. Encounter one in the natural environment is like discovering a secret culinary space concealed under the vegetation. It's a reminder that fungi are masters of chemistry, crafting fragrances that can repulse, attract, or merely astonish. From the odor of decomposition to the perfume of maple syrup, fungi execute an invisible symphony of fragrances. Each note inscribed in molecules we are merely beginning to comprehend. Certain fungi emit fragrances like coconut or almonds. As varied as blossoms in their fragrances, fungi can emit fragrances like a surprising array of familiar foods. Particular varieties possess aromas of coconut, almonds, or even marzipan. The almond-scented agaricus, for instance, possesses a perfume so close to the nut that certain foragers depend on it as a key identification characteristic. Coconut-scented lacteous species, meanwhile, appear to echo tropical delicacy despite emerging from temperate woodland substrates. These fragrances are generated by volatile substances that drift into the atmosphere, attracting fauna or merely deterring others. For humans, they become delightful peculiarities, evidence that fungi manipulate chemistry in methods that overlap with our culinary spaces and recollections. To lean close to a fungus and detect the fragrance of dessert or fruit is to experience just for a moment that the woodland itself is envisioning flavors, constructing familiar comforts into its peculiar and secret developments. Fungi are abundant with vitamin D. Few foods organically possess vitamin D, yet fungi possess a secret: they can generate their own. Like us, they manufacture vitamin D when subjected to sunlight. When ultraviolet illumination contacts a fungal surface, it transforms substances inside into this essential nutrient. For humans, vitamin D fortifies skeletal structures, supports the immune mechanism, and balances disposition. A handful of sun-dried fungi can possess as much vitamin D as a supplement. Certain cultures even position freshly harvested fungi in the sun before consuming them, amplifying their nutritional capability. It's astonishing to consider that fungi and humans possess this capacity, both depending on the identical chemistry of illumination. In the shadowy woodland, fungi might appear far removed from the sun, but when contacted by its rays, they accumulate its energy, becoming not merely sustenance, but a connection between illumination, substrate, and existence. Particular fungi possess organic toxins that radiate. In certain fungi, toxin and magnificence intertwine. There are varieties whose toxins not merely safeguard them, but also provide them the capability to radiate. These bioluminescent fungi discharge gentle emerald or azure illumination generated by biochemical reactions involving luciferin and luciferase. Researchers theorize the radiance might serve multiple purposes: deterring predators, attracting insects, or signaling to other entities. The unsettling shine is most apparent at evening when patches of woodland floor appear to shimmer with a faint otherworldly radiance. To encounter such a sight is both captivating and disconcerting. Fungi that are hazardous to contact, yet luminous, as if illuminated from within. In mythology, radiating fungi were interpreted as indications of spirits or portents, their spectral illumination suggesting at the existence of the supernatural. Research reveals the chemistry, but the amazement persists. Existence discovering methods to transform defense into radiance. The death cap mushroom possesses no antidote. Among the most feared fungi on our planet is the death cap Amanita phalloides. It appears deceptively unremarkable veil verdant cap, white stalk, a fungus you might easily confuse for consumable. But concealed within is a toxin termed amatoxin, among the most lethal substances recognized. Merely half a cap can be sufficient to terminate an adult human. Worse still, manifestations might not surface for moments, deceiving victims into false security before hepatic and renal damage commences. No antidote exists. Medical facilities can supply supportive care, occasionally even hepatic transplants, but endurance is uncertain. This fungus alone has been responsible for innumerable accidental fatalities across history. The reality that such danger conceals in such a delicate form reminds us of nature's indifference. Magnificence and terror coexist in the woodland, and fungi so frequently physicians and recyclers can occasionally possess within them a lethal secret inscribed in chemistry. A fungus previously rescued humanity from a cholera epidemic. During the 19th century, cholera was a terrifying ailment spreading through Europe, Asia, and beyond. Populations were desperate for remedies, and one improbable hero originated from the fungal realm. A fungus termed Penicillium glaucum, related to the one that provided us penicillin, was discovered to halt the cholera bacterium in its progression. The revelation wasn't fully comprehended at the time, but it provided early evidence of fungi's medicinal capabilities. Subsequently, the broader revelation of antimicrobials confirmed what this fungus had suggested all along. Fungi possess substances that can modify the trajectory of human history. Envision entire settlements trembling under the fear of ailment, only to discover relief in the unassuming development of a mold. That moment was a quiet foreshadowing of the antimicrobial revolution, to come evidence that fungi and their relatives can position between humanity and its most hazardous adversaries. Fungi can recall previous circumstances. It might sound peculiar, but fungi have been demonstrated to recall experiences. In laboratory trials, investigators observed that fungal systems subjected to particular environmental modifications like shifts in temperature, hydration, or nutrient availability could respond differently when those circumstances returned. The mycelium appeared to learn from its past, adjusting more rapidly the subsequent time around. This recollection isn't like human cognition, but it represents a form of biological recall encoded in the fungal filaments. Such adaptability might explain why fungi constitute among the most resilient existence forms on our planet. They respond to patterns, recall, and adapt. To traverse through a woodland is to traverse through a terrain animate, not merely with development, but with recollection systems of fungi recalling tempests, droughts, and conflagrations, quietly adjusting for the endurance of awe. It appears as if the substrate itself recalls, transported in the concealed filaments beneath our position. Certain fungi can endure freezing solid. During the depths of winter, when the terrain is secured in ice, you might believe fungi would disappear. Yet particular varieties are astonishingly resistant to cold. Certain can freeze solid, their hydration transformed to ice crystals, and still revive once circumstances improve. Others continue to fruit beneath snow, pushing small caps through frost as if unaffected by the season. Their resilience lies in antifreeze-like substances that safeguard their cells from harm. For beings that appear so delicate, this resilience is remarkable. It signifies fungi can establish environments as severe as tundra and alpine peaks. To encounter a fungus emerging through snow is to observe defiance in its purest form existence, quietly enduring in circumstances that would halt most vegetation. They are reminders that even in the coldest, bleakest locations, concealed realms continue their gradual and steady function of endurance. Fungi have been employed in traditional healing for millennia. Throughout cultures and ages, fungi have been honored as therapeutic agents. In traditional Chinese healing, reishi fungi are termed the mushroom of eternal life, thought to promote longevity and vigor. In Japan, shiitake fungi were previously exclusive to aristocracy as a restorative for wellness. Native populations in Siberia, North America, and Africa each cultivated their own fungal remedies, from infusions to poultices utilizing fungi to address injuries, elevated temperatures, and exhaustion. Contemporary research is now validating, discovering substances in fungi with immune-enhancing, anti-inflammatory, and even anti-tumor characteristics. What primordial physicians intuited through practice, laboratories now validate with microscopes and analyzes. When you consume fungal infusion or learn of medicinal concentrates, you're participating in a heritage extending back millennia, a demonstration of the profound connection between humans and fungi, a connection constructed from both necessity and veneration. Lion's mane fungus can regenerate neural cells in fauna. The lion's mane fungus, with its descending icicle-like projections, is not merely magnificent, but also potent. Research in fauna have demonstrated that substances within lion's mane can activate the development of neural cells. These substances, termed hericenones and erinacines, stimulate the generation of nerve growth factor, a molecule essential for restoring and sustaining neurons. This revelation has ignited intense fascination in lion's mane as a prospective intervention for neurodegenerative ailments like Alzheimer's and Parkinson's. For ages, it has been utilized in traditional Asian healing as a cognitive restorative. And now, contemporary research is revealing why. Envision a fungus, gentle and pale like a frozen cascade, possessing inside it the capacity to restore the most elaborate systems of the human cognition. It is a reminder that the answers to our most profound medical obstacles might still be concealed in the quiet recesses of the woodland. Certain fungi discharge their reproductive particles in a plume of vapor. Puffball fungi possess a particular form of enchantment. When matured, their spherical forms saturate with millions of reproductive particles, awaiting for the optimal instant to disperse. A precipitation droplet, a paw, or even an inquisitive human contact can initiate the discharge, projecting a vaporous explosion into the atmosphere. What appears like vapor is actually a glistening plume of reproductive particles, each a minute container, a potential drifting into the air current. For youngsters and gatherers, puffballs frequently become a source of fascination, a living, pyrotechnic exhibition in miniature. But beyond the amazement, this tactic is profoundly productive. In a single exhalation, trillions of reproductive particles might be transported away, securing the persistence of the variety. To observe one burst in a plume is to observe existence's tenacity in manifestation, concealed as a transient deception of vapor on the woodland substrate. Fungi assist in decomposing every descended foliage in a woodland. When fall blankets the terrain with foliage, fungi commence their patient function. Without them, the woodland would asphyxiate beneath strata of refuse. Fungi discharge potent enzymes that fragment cellulose and lignin, the resilient substances that provide timber and foliage their composition. What appears like gradual deterioration is actually a sophisticated recycling mechanism. The minerals secured within those leaves are liberated back into the substrate, prepared to nourish new development in springtime. Every blossom that flowers, every strand of vegetation that ascends owes its existence partially to this mechanism. Fungi are the invisible custodians of the woodland, securing that nothing is squandered, that mortality transforms into existence again. To wander through fall woodlands is to traverse across an invisible commerce powered by fungi, where every descended leaf becomes component of a sequence more ancient than time itself. Without fungi, existence on our planet would asphyxiate in refuse. Each season, billions of leaves descend, limbs fracture, trees collapse, and fauna expire. Without fungi, all this biological substance would accumulate perpetually, stratum upon stratum, until the world was interred in its own refuse. Fungi are the magnificent recyclers, discharging enzymes that fragment the most resilient molecules in timber, foliage, and skeletal structures. They convert what appears solid and conclusive into substrate, minerals, and atmosphere, nourishing the subsequent generation of existence. If fungi were to disappear, woodlands would asphyxiate beneath their own mass, and the sequences of restoration would cease to a standstill. Every pace you execute on a woodland substrate is feasible solely because innumerable fungal filaments have functioned relentlessly to eliminate the obstruction, dissolving yesterday's remnants into tomorrow's development. In quietness and patience, fungi maintain the planet respirable, habitable, and perpetually restoring. The invisible custodians, preventing the planet from asphyxiating in its history. Certain fungi are imperceptible until evening. During daylight, particular fungi disappear into their environment, merging with bark, foliage, and substrate. But when obscurity descends, they disclose their mystery. Bioluminescent fungi radiate gently in tones of emerald, azure, or amber, manifesting from the shadows like spectral illuminations. To discover one in an evening woodland is the sense you've penetrated another dimension where fungi illuminate their own pathway. The radiance originates from a delicate biochemical choreography within their cellular structures, comparable to the reaction that renders fireflies luminous. Certain varieties radiate solely during evening, preserving energy throughout daylight as though executing solely for the obscurity. For ages, these radiating fungi stimulated legends of woodland entities, directing or deceiving wanderers beneath the lunar sphere. Presently, they still stimulate the creativity, demonstrating that the woodland possesses its own illuminations, activated solely when the celestial bodies manifest. Fungi can cultivate algae to generate lichens. Lichens, those pigmented incrustations and decorations that adhere to geological formations and vegetation, are not singular entities, but collaborations. They are fungi that have mastered to cultivate algae or cyanobacteria. The fungi supply composition, safeguarding, and hydration, while the algae furnish sustenance through photosynthesis. Collectively, they generate entirely novel configurations of existence, capable of enduring in severe locations where neither could prosper alone: Arctic tundras, exposed precipices, arid regions, even outer space. Lichens constitute certain of our planet's most ancient and resilient colonizers, establishing geological formations to transform into substrate, adorning our world with sections of emerald, amber, and tangerine. In fundamental terms, fungi are not merely scavengers, but cultivators nurturing their collaborators in among nature's primordial illustrations of collaboration. Each lichen is a quiet narrative of collaboration, evidence that endurance frequently originates not from rivalry, but from functioning collectively across realms of existence. Particular fungi are consumable solely following preparation. Not all fungi can be consumed uncooked, even if they aren't toxic. Certain possess mild toxins or indigestible substances that are neutralized solely through preparation. Morels, extensively praised by culinary experts, are one such illustration. Uncooked, they can generate gastric disturbance, but following salting or roasting, they convert into delicacies with nutty, earthy flavors. Others, like shiitakes, discharge more abundant fragrances and minerals solely when thermal energy unlocks their chemistry. It appears as though combustion completes their narrative, converting potential danger into sustenance. For gatherers, this comprehension has been transmitted across generations. The appropriate preparation converts peril into pleasure. The conversion is almost alchemical, the elementary gesture of preparation, transforming something questionable into something nutritious. Fungi remind us that sustenance is not consistently straightforward. Occasionally, it necessitates reverence, patience, and ceremony to reveal what exists concealed within. Certain fungi are so acrid, they cannot be consumed. Not every fungus desires to be consumed. Certain protect themselves with flavors so intensely acrid that even the most ravenous fauna will expel them. The acrid bolete, for illustration, appears almost identical to consumable relatives, but provides a flavor so harsh it can devastate a preparation with merely a morsel. These protective substances are nature's method of discouraging consumers without employing toxins. To humans, acridity is frequently an alert, a sensory notification that instructs us to cease. In the fungal domain, it is one additional mechanism in the collection of endurance. Yet even these unpalatable fungi contribute to environments, recycling substance, and enriching substrates. They remind us that not everything in the woodland is intended for us, that flavor itself is component of the dialogue between varieties, a quiet interaction that determines who consumes and who is abandoned alone. Fungi can generate organic hallucinogens. Among the most renowned and contested fungi are those that manufacture hallucinogenic substances such as psilocybin. These biochemicals can profoundly modify human awareness, generating visions, distortions of temporal perception, and a sensation of unity beyond the individual. For ages, such fungi were utilized in spiritual and shamanic ceremonies, thought to unlock passageways to the transcendent. In recent periods, researchers have commenced re-examining these fungi with restored fascination, investigating their capacity to address depression, anxiety, and dependency. The reality that a fungus can modify awareness so profoundly is remarkable. It indicates that fungi not merely recycle the woodland, but can also restructure the human cognition. Whether perceived as sacred, hazardous, or restorative, these fungi position at the convergence of biology and enigma, possessing within their delicate caps the capability to transform actuality itself. Primordial cave illustrations might portray fungal utilization. In caverns distributed across Spain and Algeria, prehistoric illustrations depict human silhouettes grasping objects that resemble fungi. Certain academics interpret these as confirmation that primordial humans not merely collected fungi for sustenance, but also for spiritual encounters. The illustrations depict dancing silhouettes, explosions of pigmentation, and designs that resonate the categories of visions hallucinogenic. Fungi can stimulate. While we cannot be definite, the likelihood that humans were investigating fungal conditions of cognition tens of millennia previously is captivating. It indicates that fungi have been influencing civilization, ceremony, and creativity since the genesis of artistic expression itself. To envision primordial populations assembled around combustion, illustrating fungi on cavern surfaces as representations of voyages into the imperceptible, is to experience a profound connection across millennia to the manners fungi have consistently stimulated both endurance and narrative. Fungi can be utilized to manufacture biodegradable wrapping. In a civilization grappling with synthetic refuse, fungi might provide an answer. Mycelium can be cultivated into configurations to generate lightweight, resilient wrapping substances. Following dehydration, the substance resembles polystyrene foam, but is entirely biodegradable. Corporations are currently experimenting with fungal wrapping to substitute styrofoam in transport containers, electronics, and even furnishing cushioning. Following utilization, it can be composted, returning benignly to the substrate. The mechanism utilizes agricultural refuse as nourishment for the mycelium, signifying the fundamental components are plentiful and sustainable. It's remarkable to contemplate that the identical entity emerging fungi in the woodland could eventually cushion your packages or safeguard delicate merchandise, abandoning no contamination. Where synthetics adhere to the planet for ages, fungi guarantee a sequence of generation and restoration, providing optimism that wrapping itself can eventually become component of the organic circulation of existence. Certain mycelium functions as an organic flame inhibitor. Investigators have revealed that particular categories of mycelium, when cultivated into substances, resist combustion organically. Unlike synthetics or timber which combust and discharge harmful vapor, mycelium composites carbonize and smolder without generating hazardous emissions. This renders them promising as environmentally conscious insulation, furnishings, and construction substances. Envision barriers lined with fungal systems, resilient and secure, safeguarding dwellings not merely from the climate, but from combustion. The mystery resides in the chitin and polysaccharides of the fungal cellular boundaries which resist combustion. The natural world through fungi has constructed a substance humans are merely commencing to value. Mycelium flame resistance could revolutionize construction, rendering structures both more secure and more ecological. To comprehend that the identical concealed filaments that interconnect a woodland substrate could also protect a dwelling from combustion is a reminder of fungi's adaptability, a quiet realm providing mechanisms for tomorrow. Fungi could substitute hide with mycohide. Hide has long been appreciated for its resilience and pliability, but its manufacturing is material demanding and environmentally expensive. Presenting mycohide, a substance cultivated from fungal mycelium. It can be nurtured in layers, processed, and completed to replicate the appearance and sensation of traditional hide. The outcome is resilient, permeable, and entirely biodegradable. Engineers are currently fabricating footwear, satchels, and furnishings from this innovative substance. Unlike fauna coverings, which require months or seasons to manufacture, mycohide can be cultivated in weeks with considerably less hydration and no cruelty engaged. Its consistency can be modified gentle and suede resembling, or polished and lustrous. To consider that the identical system that generates fungi can also transform into a garment or a seat is almost surreal. Fungi are not merely physicians and recyclers, but creators, providing humanity substances that connect magnificence, morality, and ecological responsibility. Particular fungi possess substances that dissolve frozen water. In woodlands where cold seasons are extended and severe, certain fungi possess mysteries that enable them to persist. Particular varieties manufacture antifreeze-resembling proteins and carbohydrates that maintain their cellular structure secure even when the atmosphere congeals. These substances reduce the congelation threshold of hydration, preventing acute frozen crystals from generating and rupturing delicate tissues asunder. In the substrate, this permits fungi to persist fragmenting foliage and timber when most entities remain inactive. More remarkable still, these molecules can occasionally infiltrate into the surroundings, releasing the constraint of frost surrounding the fungus. Investigators are examining these organic antifreezes as templates for more secure methods to safeguard cultivation from frost or de-ice pathways without severe biochemicals. It is modest to envision a minute fungus no larger than your palm, quietly restructuring its frozen environment, reminding us that durability is frequently discovered in the minutest, gentlest recesses of existence. Fungi can withdraw minerals from geological formations. Though they possess no implements or musculature, fungi are remarkable excavators. Certain varieties discharge biological acids that gradually dissolve geological material, releasing minerals like calcium, magnesium, and potassium. In accomplishing this, they convert lifeless stone into productive substrate, generating foundations for woodlands and terrains. This mechanism might have commenced more than a billion seasons previously when fungi initially traversed across exposed terrains, establishing the pathway for vegetation to establish terrestrial surfaces. Even presently, lichens collaborations between fungi and algae inscribe their trajectory across precipices and memorial stones, minute but persistent. Across ages, their function reshapes entire mountainous regions. Researchers presently envision biomining innovations stimulated by these fungi, extracting scarce components with considerably reduced devastation than human apparatus generate. To position before a geological prominence and comprehend that it is being quietly consumed molecule by molecule by invisible fungal filaments is to observe patience itself converted into capability. Certain fungi prosper on radioactive contamination. In locations where human existence weakens, fungi occasionally prosper. At Chernobyl and additional polluted locations, researchers have discovered fungi developing in destruction saturated with radiation. These fungi possess melanin, the identical pigment in our epidermis. But here it appears to fulfill another function. Rather than protecting alone, it appears to convert radiation into power, a peculiar mechanism termed radiosynthesis. Envision fungi executing a form of photosynthesis, not with solar illumination, but with radiation we regard lethal. These revelations suggest at remarkable potentials fungi that could assist purifying radioactive contamination or safeguard space travelers journeying through the severity of cosmic space. In the devastation of catastrophe regions, fungi remind us that existence adjusts even to the inconceivable, converting hazard into sustenance. What for us constitutes toxin becomes for them energy, evidence of nature's remarkable capacity to endure where endurance appears unfeasible. Fungi might have assisted vegetation establish terrestrial surfaces. When the initial verdant vegetation departed the seas to establish on terrestrial surfaces, they confronted a desolate realm exposed. Geological material, no substrate, and minimal minerals. But they weren't isolated. Fossils demonstrate that fungi were currently present, prepared to collaborate with them. These primordial confederations enabled vegetation to withdraw minerals from geological material distributed by fungal systems in compensation for carbohydrates. Across time, this collaboration generated the initial delicate substrates, rendering it feasible for woodlands and meadows to manifest. Without fungi, vegetation might have never established foundations on terrestrial surfaces, and our planet might still be quiet, desolate, and colorless. Every vegetation, every grassland, every strand of vegetation possesses the inheritance of this collaboration. When you traverse across a terrain presently, you are traversing on ground established by fungi hundreds of millions of seasons previously. A quiet obligation inscribed into the actual composition of our planet's animate verdant covering. Certain fungi establish collaborations with coral formations. Though we consider fungi as woodland inhabitants, fungi also establish their habitats in the ocean. Oceanic fungi have been revealed existing alongside corals, constructing invisible filaments into the vibrant architecture of formations. These collaborations might assist regulating minerals, safeguarding corals from contaminants, or stabilizing delicate formation environments. Though minimally examined compared to their terrestrial relatives, oceanic fungi could be essential to the endurance of coral formations under the pressures of climate modification. To envision fungi drifting among coral organisms is to comprehend that the fungal realm is not confined to substrate and vegetation. It extends into saline water, interconnecting existence in concealed manners. If corals constitute the architects of formations, fungi might be their custodians, assisting them persist. Even beneath the aquatic currents, fungi and their relatives remind us that existence is never isolated. It is consistently constructed upon collaborations. Fungi can replicate both sexually and asexually. Fungi are experts of adaptability. They can discharge reproductive particles asexually, manufacturing innumerable genetic duplicates in a productive explosion of replication. This tactic enables them to establish rapidly, dispersing through substrate and atmosphere with remarkable scope. But fungi also replicate sexually, trading genetic substance with others to generate diversity. This provides them the flexibility required to confront transforming circumstances, parasites, or novel environments. Certain varieties even alternate between mechanisms depending on their situations, maximizing their endurance probabilities. Envision an entity with two entirely distinct tactics for generating more of itself, one for velocity, one for durability. It is a degree of adaptability few existence forms possess. Each fungus you observe might be the result of a cloning heritage or a genetic combination, a parent reminder that fungi possess within them not merely one manner of existing, but numerous. Certain varieties possess over 20,000 distinct genders. In the fungal realm, replication exhibits diversity to remarkable extremes. Certain varieties possess tens of thousands of mating classifications, the equivalent of genders. The split-gill fungus, for illustration, might possess more than 23,000. These are not genders in the human perception, but compatibility sequences inscribed into their DNA. The consequence is identical. Nearly any two specimens can mate successfully, maximizing prospects for replication. This mechanism prevents inbreeding and stimulates a dazzling diversity of genetic blends, securing durability across generations. Where humans envision gender as elementary and binary, fungi detonate the notion into tens of thousands of potentials. To contemplate a fungus's mating mechanism is to perceive the ingenuity of evolution itself, reminding us that existence is not restricted to our classifications. For fungi, diversity is not the anomaly. It is the principle woven into their actual essence. A single puffball can discharge trillions of reproductive particles. When a puffball achieves maturation, it converts into a sphere saturated with a delicate powdery quantity of reproductive particles. A precipitation droplet, a descending branch, or the contact of an inquisitive hand can initiate the discharge, projecting a vaporous plume into the atmosphere. What appears like a puff of powder is actually a tempest of microscopic existences. A single substantial puffball can discharge trillions of reproductive particles, exceeding the quantity of humans who have ever existed. Most reproductive particles will drift away, contacting in locations too arid or desolate to develop, yet certain will discover the appropriate circumstances and commence novel populations, persisting the heritage. This tactic concerns quantity's overwhelming probability with absolute abundance. Observing a puffball burst is like observing the sea. Woodland respire instant of discharge, where invisibility transforms apparent and potential disperses into the air current by the millions. Reproductive particles can be discovered drifting elevated above urban centers. The fungal domain is not restricted to the woodland substrate. Reproductive particles ascend on atmospheric flows, transported elevated and elevated until they drift considerably above structures and towers. Research have discovered them thousands of measures above settlements, combining with particles and pollen in the atmosphere. Certain are even transported into precipitation systems, descending subsequently with precipitation onto remote terrains. Every inhalation we execute in a settlement possesses traces of reproductive particles, fragments of remote woodlands, cultivations, and substrates. Even enclosed by concrete, we are still linked to the concealed systems of fungi. In essence, the atmosphere itself is a connection between natural and urban, transporting reproductive particles as persistent messengers. The subsequent time you traverse down a crowded pathway, recall that the fungal domain is with you, drifting invisibly overhead, connecting your respiration to environments you might never encounter. Fungi might affect planetary climate. Invisible though they are, reproductive particles might influence something as immense as the climate. Minute and plentiful, they ascend into the atmosphere where they function as nuclei for hydration droplets. Surrounding these particulates, precipitation systems can generate. In this manner, fungi might assist determining when and where precipitation descends, engaging quietly in our planet's climatic sequences. Woodlands might not merely recycle minerals subterranean, but also summon precipitation from the atmosphere, dispatching reproductive particles aloft to coax hydration into precipitation systems. The concept remains under examination, but it indicates that fungi affect more than substrate. They might extend into the actual designs of the atmosphere. Envision precipitation droplets generating around reproductive particles discharged in a remote woodland, descending moments subsequently across terrains and waterways. Fungi obscure the boundary between terrain and atmosphere, reminding us that existence does not terminate at boundaries, but circulates skyward, externally, and omnidirectionally. Particular fungi can assimilate heavy metallics. In substrates contaminated by human manufacturing, fungi frequently advance as quiet physicians. Particular fungi possess a remarkable capacity to assimilate and secure away heavy metallics like lead, mercury, and cadmium. Their mycelial filaments function like absorbents, extracting toxins from the surroundings and concentrating them inside their reproductive structures. This mechanism, termed mycoremediation, provides optimism for purifying contaminated terrain without excavating, combusting, or biochemicals. Though the fungi themselves become hazardous to consume, they have currently fulfilled their Function, converting poisoned terrain into productive substrate again. Envision a devastated terrain scattered with refuse where fungi emerge defiantly functioning as animate purifiers. They are nature's transformers, transmuting hazard into something confined. In their quiet function, fungi disclose a design for durability that even in the most devastated recesses of the planet, restoration can commence not with apparatus, but with the quiet patience of filaments in the substrate. Fungi can be utilized to purify petroleum contamination. When petroleum penetrates substrate or hydration, the devastation can persist for decades. But fungi might provide a sophisticated answer. Particular fungi are capable of fragmenting hydrocarbons, the actual molecules, comprising petroleum into benign substances. Their mycelium discharges enzymes that fragment harmful sludge, converting dark slicks into productive terrain where vegetation can develop again. In trials, regions treated with fungi have converted from petroleum wastelands into flourishing terrains within weeks. Avians and arthropods return, and the terrain respires once more. This methodology, component of the extensive domain of microremediation, indicates fungi could execute a function in restoring certain of humanity's most significant environmental catastrophes. Envision a petroleum-saturated coastline gradually converting verdant again, not through human engagement alone, but with the assistance of fungi dispersing their filaments through the contaminated terrain. The natural world, it appears, possesses the remedy within the actual entities we frequently disregard. Fungi have been dispatched into orbital trials. The peculiar durability of fungi has rendered them subjects of orbital investigation. Researchers have dispatched fungi and fungal reproductive particles aboard spacecraft to examine their endurance in microgravity and cosmic radiation. To their astonishment, numerous fungi not merely endured, but persisted to develop. Certain varieties even appeared to adjust, modifying their chemistry in response to the severe surroundings. Such investigations suggest that fungi could execute a function in prospective orbital missions, potentially recycling refuse, manufacturing sustenance, or even protecting space travelers from radiation. There is even conjecture that resilient reproductive particles might endure interplanetary voyages, drifting through space to establish novel realms. Whether or not this is accurate, fungi in orbit remind us that existence is remarkably adaptable. A fungus that can emerge in the vacuum of space extends our creativity of where existence can proceed, indicating that our planet's concealed domain might possess cosmic capacity. Without fungi, existence on our planet would not be feasible. Remove fungi from the world, and existence deteriorates. Woodlands would asphyxiate on their own debris, minerals would disappear from substrates, and sequences of deterioration and restoration would cease to a standstill. Without fungal collaborations, most vegetation could not assimilate sufficient minerals to endure. And without vegetation, fauna, including humans, would possess no sustenance. Even the oxygen we inhale owes component of its equilibrium to fungi, which maintain environments that manufacture and recycle it. Fungi are the recyclers, the collaborators, the physicians, the quiet architects of our planet. They function invisible, yet their non-existence would be devastating. Every meal, every inhalation, every verdant terrain exists because fungi are present equilibrating the mechanism. To comprehend this is to realize that fungi are not secondary figures in the narrative of existence. They are its foundation. Without them, the platform would be vacant, and the performance of existence could never commence. And so we float to the conclusion of our quiet voyage through the domain of fungi. From radiating illuminations in the woodland evening to reproductive particles traveling invisible air currents above the moon, settlement to fungal systems more ancient than woodlands themselves, we've traversed through a realm that is simultaneously concealed and fundamental, delicate yet indestructible. Fungi remind us that existence is not consistently prominent or apparent. Considerable of the function of this world is executed in quietness beneath our position in filaments so delicate they can penetrate through the apertures of stone. Fungi instruct patience, durability, and conversion. They recycle mortality into existence, accumulate hydration for the parched, nourish titans and arthropods alike, and even communicate to vegetation through subterranean systems. Without them, there would be no bread ascending in ovens, no woodlands ascending toward the atmosphere, no equilibrium in the perpetual sequences of our planet. As you permit these contemplations to settle, envision the gradual rhythm of the mycelium beneath you, a cardiac rhythm of the substrate, constant and tranquil. Envision reproductive particles drifting like cosmic, particles transporting potential into every recess of the atmosphere. Envision the radiance of fungi in the obscurity quiet illuminations to remind you that even in shadow, existence persists to radiate. This is the solace of science communicated gradually, that our world is more peculiar, more abundant, and more interconnected than we can ever completely perceive. And that by pausing to observe, we glimpse the remarkable in the typical. If you've appreciated this voyage and you'd like to float through additional realms of inquisitiveness and amazement, we'd appreciate if you would subscribe and distribute your reflections in the feedback. It assists our modest collective of visionaries and science admirers expand. But for now, there is nothing additional you require to execute. You can permit the narrative of fungi to diminish like the concluding illumination of day, abandoning solely tranquility behind. If rest arrives, permit it to transport you gently. If you are still conscious, you are invited to remain, to listen again, or to permit the subsequent presentation to persist your voyage into the quiet marvels of the cosmos. Rest peacefully and recall, our world is abundant with concealed wonders. Occasionally, they ascend overnight like fungi following precipitation. Occasionally, they have been awaiting for you all along, beneath the surface. Good night. Certain fungi possess flavors like cocoa. Fungi are typically associated with earthy, savory flavors, but certain varieties astonish with delicacy. Handful of uncommon fungi manufacture fragrances and flavors evocative of cocoa or chocolate. Researchers theorize these flavors originate from distinctive aromatic substances, molecules that replicate the identical sensations cocoa generates on our palates. Though not as prevalent as truffles or candy caps, these cocoa-resembling fungi remind us how varied the fungal spectrum can be. Envision traversing through a woodland, anticipating moist earth and decomposing foliage, only to detect the scent of something heated and delicate, like a confectionery in the center of the wilderness. For culinary experts, these fungi unlock peculiar potentials, desserts flavored not with cacao seeds, but with woodland fungi. It's another manner fungi obscure the boundaries of all. Anticipation, providing astonishments not merely in their configurations and pigments, but in flavors that can sense like in resonance of human satisfactions. Others radiate emerald like beacons. In tropical woodlands, particular fungi project an unsettling radiance that can arrest you in your progression. These bioluminescent fungi emanate with an emerald illumination, occasionally vivid enough to illuminate surrounding foliage. The radiance is generated by a biochemical reaction engaging luciferin and luciferase comparable to the mechanism fireflies utilize. Researchers theorize the illumination might assist attracting arthropods during evening, transporting reproductive particles to novel locations. To discover them in the obscurity is to sense as though the woodland itself has ignited beacons on the terrain, radiating gently in the vegetation. For ages, wanderers narrated accounts of fairy combustion and fox combustion, enigmatic illuminations that shimmered from decomposing timber. Presently we comprehend. They are fungi disclosing their concealed luminescence. They remind us that even in obscurity, existence discovers methods to radiate generating minute emerald signals in the evening to transport its narrative forward. Fungi previously developed as elevated as vegetation. Hundreds of millions of seasons previously, our planet's terrains appeared remarkably different. Long before towering conifers or oaks, enormous fungi, termed prototaxites, dominated the terrain. These peculiar entities developed up to 30 feet, elevated, rendering them the most elevated existence configurations of their epoch. Ascending like columns, they scattered primordial terrains in a realm where arthropods had merely commenced to achieve flight. Fossils indicate these titans might have appeared like enormous vegetation trunks, yet they were neither vegetation nor timber, but fungi. Envision a prehistoric plain with towering fungal pillars, positioning isolated against a desolate horizon. They established the terrain for the woodlands to manifest, fragmenting down geological material, constructing substrate, and forming environments. Presently, fungi are predominantly minute and transient, but their forebears previously dominated the planet protectors of a forgotten epoch when fungi, not vegetation, were the titans of the terrain. Certain fungi can endure absolute dehydration. Hydration is typically regarded the fundamental of existence, but certain fungi can persist even when every droplet is eliminated. Particular arid fungi and lichens can endure absolute dehydration, desiccating until they are apparently non-viable. Yet, when hydration returns, they revive, persisting development as if nothing transpired. This remarkable durability originates from particular carbohydrates and proteins that safeguard their cellular structures from deteriorating during aridity. It enables them to establish the most severe arid regions and geological prominences locations where minimal entities can persist. Researchers examine these fungi for indications regarding how existence might endure on Mars or additional arid worlds. Envision a minute filament of fungus, fragile and inactive for seasons, reviving back to existence with the contact of precipitation. In their quiet persistence, these entities demonstrate use that endurance occasionally signifies not confronting circumstances, but awaiting, absolutely motionless, until the instant is appropriate. Particular fungi assist cultivation resist ailment. Beneath terrains of wheat, corn, or rice, invisible confederates are functioning. Mycorrhizal fungi, which exist in collaboration with vegetation roots, not merely supply minerals, but also strengthen vegetation against ailment. By activating a vegetation's immune mechanism, fungi render cultivation more resistant to parasites and contaminants. In certain instances, they even surpass harmful microorganisms, directly obstructing them from assaulting roots. Cultivators are commencing to harness this primordial collaboration, utilizing fungal inoculants to diminish dependence on biochemical pesticides. Envision cultivation strengthened not by applications, but by quiet subterranean confederates constructing protective networks. These collaborations are reminders that agriculture is not a conflict against the natural world, but a partnership with it. Precisely as woodlands flourish on fungal systems, cultivations of tomorrow might discover their most significant durability not in biochemicals, but in the identical, modest fungi that have been sustaining vegetation for millions of seasons. Fungi are utilized to manufacture life-preserving pharmaceuticals. Beyond antimicrobials, fungi and their relatives are biochemical repositories. Substances obtained from fungi are utilized to reduce cholesterol, suppress immune, rejection in organ transplantations, and even combat malignancy. Lovastatin, a pharmaceutical that revolutionized cardiac medicine, originates from fungi. Cyclosporine, essential for transplantation recipients, was revealed in a substrate fungus. Investigators persist to examine the fungal domain, pursuing for the subsequent revelation, concealed in a woodland or grassland. For ages, traditional healing has depended on fungi, but contemporary research is disclosing precisely how profound their pharmacological capabilities are. Each cap, Each filament of mycelium might possess a molecule that could eventually preserve existences. To traverse through the wilderness is in essence to wander through an animate dispensary where remedies are awaiting, patiently to be revealed concealed beneath vegetation and bark inside the quiet function of fungi. The initial antimicrobial, penicillin, originated from a fungus. In 1928, Alexander Fleming observed that a mold Penicillium notatum had eliminated bacteria on a cultivation dish in his laboratory. This fortuitous observation resulted in penicillin, the initial extensively utilized antimicrobial, which proceeded to preserve millions of existences during World War II and thereafter. Though not a fungus, Penicillium constitutes the identical magnificent fungal domain, demonstrating once again how profoundly fungi influence human chronicle. The revelation of penicillin modified medicine permanently, converting previously lethal contaminations into manageable circumstances. It is remarkably inspiring to contemplate that such a monumental transformation originated not from human creation alone, but from the quiet function of a fungus developing in a neglected dish. That mold possessed within it the capability to reconstruct the narrative of medicine, reminding us that fungi are not merely recyclers of the woodland, but protectors of human endurance in manners we never anticipated. Fungi render bread ascend and wine ferment. Every loaf that elevates in the apparatus, and every vessel that glistens in the evening, owes a quiet obligation to fungi. Yeast's single-cellular relatives of fungi consume carbohydrates and discharge carbon dioxide and ethanol. In bread mixture, those bubbles become secured in gluten's elastic mesh, expanding the loaf like a gradual dawn. In wine, the identical exhalation becomes effervescence or the motionless quietness of a completed vintage. A sourdough initiator is its own minute environment yeasts, natural and cultivated, existing alongside benevolent bacteria, each modifying to temperature, grain, and duration. Bakers comprehend to interpret its disposition by fragrance and resonance, a gentle hiss like a dormant current. Vintners equally communicate of terroir, partially in microbial expressions, the invisible arrangements of regional yeasts that influence grapes toward flavor. Fermentation is chemistry, certainly, but it is also coordination, fungi transporting carbohydrates toward sustenance and festivity, one invisible exhalation at a moment. Fungi have stimulated entire categories of artistic expression, from embroidered traditional designs to embellished illustrated terrain manuals. Fungi have extensively traversed from the woodland substrate onto canvas, textile, and page. There, profiles are compelling domes and decorations, lamellae like cathedral chambers, stalks that ascend with the performer's elegance. Art Nouveau adopted their contours. Botanical illustrators pursued their delicate pigments. Ceramicists finished caps in precipitation-cleansed luster. Contemporary engineers improvise on the ribbed mathematics beneath the cap to conceptualize illuminations, domes, and lattice barriers. Photographers position low to the terrain to capture bioluminescent aureoles, converting nocturnal woodlands into stellar formations. Even juvenile publications depend on the fungus's mythical narrative atmosphere, a representation of astonishment, an entrance to a minute luminous realm. The attraction is more than optical. Fungi are allegories for manifestation, for realms concealed until the circumstances are appropriate. Artistic expression persists returning to them because they are both extraterrestrial and recognizable, a dialect of configurations that communicates observe more closely. Certain fungi can vocalize with ultrasonic pulses. Fungi possess no oral cavities. Yet investigators documenting ultra-responsive impulses have identified faint pulse-like explosions as fungi expand in mycelium, reorganizes liquid and tension in their structures. Whether these microresonances are authentic vocalizing or merely minute biomechanical discharges is still being investigated. But the consequence is captivating a woodland, transmitting at frequencies we seldom perceive. In laboratories, researchers also quantify electrical impulses circulating through mycelial filaments' rhythmic elevations that accelerate, decelerate, and aggregate like phonemes. Creators convert those designs into perceptible tones, converting fungal impulses into atmospheric composition that ascends and descends with moisture, illumination, or contact. Attend sufficiently long, and you commence to envision an ensemble beneath the substrate impulses synchronizing development, material distribution, or pressure reactions. The manner of cardiac rhythm and respiration establish tempo for a physique, whether dialect or consequence. The pulses remind us that animate configurations possess rhythms, and the fungus's rhythm is patient and exact. Fungi have been revealed, existing inside geological formations. In arid regions so dehydrated that air current appears to refine the framework of the realm, existence withdraws into stone. Endolithic fungi position themselves within mineral apertures, delicate as filament and resilient as aged cordage, existing where temperatures oscillate dramatically, and hydration manifests as speculation more than precipitation. In Antarctica's dehydrated depressions, they occupy the translucent surfaces of quartz, consuming the dim filtered illumination that penetrates a handful of millimeters profound. Their chemistry is utilitarian, and primordial acids consume minerals. Pigments protect radiation, and metabolism decelerates to the minimal ignition, prepared to intensify when a coating of liquefied water returns. To articulate existence is durable, is excessively direct. Existence is resourceful. These geological inhabitants inscribe their chronicle in microns, sculpting patience into geology. Unseal a stone, and you might discover not vacancy, but a settlement of filaments, a reminder that environment is more extensive than we contemplate, that the boundary frequently commences precisely beneath the epidermis of the realm. Fungi can convert ants into undead. An ant traverses under a foliages, verdant covering and a reproductive particle contacts, a single nucleus of a fungus that comprehends its host intimately. Inside, the fungus expands like a murmured indication, penetrating through musculature while conserving the cognition precisely sufficient to direct conduct. Compelled by biochemistry, the ant descends to an elevation optimal for dissemination, secures down on a channel in a mortality grasp, and congeals. Subsequently, the reproductive stalk manifests, fragmenting the exoskeleton like an obscure blossom, discharging reproductive particles over the woodland pathway beneath. This is the notorious undead ant narrative exactus mechanism, and yet still peculiar. It is terror diminished to evolutionary reasoning. By directing conduct, the fungus positions its descendants in the appropriate air current. The natural world does not ethicize. It formulates tactics. And here, tactic is coordination and assent, a secure, a motionlessness, and consequently, a fungus can project its powder into the circulating atmosphere. Cordyceps fungi erupt from arthropods forms. Cordyceps are the melancholic creators of the fungal realm, converting the minute spectacles of arthropod existence into peculiar motionless compositions. A larva solidifies into a foundation. A beetle transforms into substrate for a slender tangerine projection. A arachnid arrested mid-posture develops delicate projections. Each variety of cordyceps is particular developed for a specific host is secured. Mechanism closeness millions of seasons in the synth. Formation. Beneath the exterior, enzymes dissolve. Chitin filaments saturate cavities. The form is restructured from internally until the fungus advances into the illumination to reproduce. The vision is disconcerting because it obscures our organized classifications fauna into construction, parasite into cultivator. Yet, cordyceps also restores minerals to the woodland and regulates arthropod communities, an environmental equilibrium inscribed in unsettling form. To observe one is to position both, disgusted and mesmerized. Reminded that endurance frequently assumes configurations, we discover magnificence solely following the initial tremor transitions. Certain fungi appear like minute avian dwellings. Kneel in moist foliage debris, and you might discover a diminutive-sized vessel cradling lustrous spheres. These are avian-dwelling fungi constituents of the Nigellariaceae, and those spheres are peridiole's reproductive containers, prepared for a precipitation-propelled journey. When a droplet descends, it contacts the vessel precisely appropriately, projecting the peridioles externally like pebbles from a projectile. An adhesive filament assists them secure onto traversing branches or pelage, transporting toward novel terrain. The configuration is flawless mechanics, proportioned to a precipitation droplet audacious mathematics, collision trajectory, path. They're effortless to overlook until you've observed them once. And subsequently, the woodland transforms abruptly abundant of miniature dwellings, entire nurseries functioning in quietness at the substrate level of the realm. Avian-dwelling fungi diminish separation between fantasy and construction, a mythical narrative configuration executed with mathematical elegance. Each precipitation tempest as percussion for the subsequent generation. Others appear like digits extending from the terrain. In shadowed recesses, assemblages of obtuse dark clubs project from the substrate like appendage partially recalled. Deceased individuals' digits, xylaria, polymorpha azure gray initially, obscuring with maturation. Elsewhere, coral fungi elevate pale branching projections in delicate illuminations. These configurations deceive the vision because they sense gestural and extension, a summoning when they are merely reproductive structures calibrated to discharge reproductive particles productively in circulating atmosphere. The ghastly designations are our individual interpretation, our inclination to discover ourselves in everything. Observe extended, and they, performance quiets. These digits are timber recyclers generated from interred roots charting where vegetation previously positioned. They ascend, discharge reproductive particles, and deteriorate back to shells, but the mycelium beneath endures, patient as foundation. It's a beneficial instruction considerable of an existence can be concealed and still be the most authentic component of the narrative. Certain fungi are enveloped in mucilage. Glistening caps accumulate with a coating of precipitation and resin. Certain are so glossy you could nearly observe your image. The mucilaginous appearance isn't a peculiarity as considerably as tactic. In boletes and swillus varieties, a viscous cap assists preserving hydration and might safeguard delicate tissue from desiccating air currents. In the audacious stinkhorns, mucilage the glibba adorns a different facade, a repulsive sugary attraction that replicates decomposition and attracts diptera. They contact, consume, and depart adorning reproductive particles like dusting powder on their appendages, a transportation facility compensated in deception. To us, mucilage interprets as an alert, but to fungi, it is an apparatus hydration stratum, precipitation barrier, perfume, announcement. Contact one new digits. Emerge tachia sensory notation that the woodland is constructed on utility before visual appeal. Even luster possesses a function to execute. Fungi can be vivid azure, violet, or rose. Certain mornings, the woodland neglects its terrestrial tones. Indigo, lacteous discharge azure. Amethyst deceivers distribute gemstone vivid fragments among brown foliage. Hygrocybe ascend in confection rose and citrus amber on ancient grasslands. The pigments fulfill numerous functions pigments that protect from illumination, antioxidants, impulses to arthropods, or merely chemistry that accompanies along with additional characteristics. To encounter a azure fungus is to experience a minute impact of incredulity, like discovering a tropical aquatic in a depression. Photographers pursue these instants, a cobalt cap beneath vegetation, a violet stalk against russet oak. Pigmentation in fungi is a range of endurance tactics and occurrences that interpret as amazement to human perception. The spectrum reminds us that woodlands are not single-toned. They are pigmented glass apertures positioned horizontal, illuminated from above by precipitation illumination, adorned from beneath by the quiet chemistry of the substrate. Fungi can endure in the most severe arid regions. In the dehydrated quietness of arid regions, where vegetation contort into spines and fauna disappear into excavations, fungi still endure. Certain conceal and concealed configurations, existing within geological formations, protected from air current and solar radiation. Others envelope themselves in lichens, connecting with algae or cyanobacteria to generate animate coverings across stone. These collaborations manufacture sustenance from solar illumination, while fungi supply protection and hydration accumulation. Even in the Atacama arid region, among the most dehydrated locations on our planet, researchers have discovered fungal existence, quietly adhering to saline crystals and mineral channels, enduring on transient vapors and condensation. Their durability is astounding. Where precipitation measures millimeters per 10 seasons and temperatures vary dramatically, fungi persist functioning in minute intervals between aridity and opportunity. It is endurance as simplicity, existence streamlined to the most fundamental biochemistry. To discover them is to comprehend that the most audacious life forms are frequently the quietest. Certain fungi develop through frozen water. In the depths of winter, when the woodland congeals beneath accumulated precipitation and the ground acquires a frozen crunch, certain fungi quietly pierce through. They aren't merely robust to cold. They utilize it. Winter varieties such as Flammulina veliotypes, the velvet foot fungus, develop during winter, utilizing the decelerated deterioration of timber beneath the frozen water as a deliberate repast. Their caps frequently accumulate frozen precipitation like pigmented barrettes, yet persist in releasing reproductive particles. Their cellular membranes include substances that maintain them pliable at temperatures that would congeal most existence. For gatherers, these fungi offer an improbable discovery, a dash of pigmentation on an otherwise colorless terrain. And for researchers, they constitute a puzzle of durability. How do they maintain functioning when all surroundings encourages inactivity? The response resides in adaptability biochemistry, bent to the limitations of the epoch and rewarded with endurance. Fungi establish entire subterranean corridors for microorganisms. Mycelium is not merely a system for itself, but additionally for others. Investigations have demonstrated that bacteria utilize fungal filaments like corridors, journeying along them to disperse through substrate more productively. The delicate filaments supply a constant exterior, directing microorganisms across otherwise unfeasible separations. In compensation, bacteria occasionally distribute minerals or assist the fungus, generating miniature collaborations. This generates a subterranean framework where innumerable, microscopic varieties coexist and engage. It is a concealed environment of corridors, intersections, and transactions, intransactable yet essential. Without fungi, numerous microorganisms would be isolated in minute substrate recesses incapable to disperse. With them, the terrain transforms a thriving metropolis abundant of circulation and commerce. To envision substrate as vacant earth is an error. It is more resembling a settlement abundant with linkages, and fungi, with their perpetual filaments, are the architects establishing pathways for existence to journey. Certain fungi emit fragrances precisely like recent bread. Elevate the cap of a recently collected champignon or a terrain fungus, and you might observe a perfume, remarkably recognizable heated, fermented bread directly from the apparatus. This fragrance originates from volatile substances additionally manufactured by yeasts during fermentation. Distributed chemistry that connects fungi to confection preparation. For gatherers, the fragrance can be an indicator to identification, a sensory acknowledgement between varieties. The fragrance is more than agreeable. It is evolutionary tactic. Aromatic substances can attract arthropods or fauna, stimulating them to contact against reproductive particles and transport them forward. For humans, the connection sense is almost peculiar. To inhale the perfume of bread in the center of a woodland is to encounter satisfaction in an unanticipated location, as though the culinary space and the natural realm had momentarily combined. It's a reminder that the boundaries we envision between the cultivated and the organic are frequently more delicate than they appear. Others emit fragrances like cinnamon or anise. Not all fungi possess terrestrial or musty fragrances. Certain discharge perfumes that replicate condiments from remote culinary spaces. Anise-fragranced mushroom varieties exude the delicate licorice-resembling perfume of anise, while particular lactareous varieties emit fragrances distinctly of cinnamon. These fragrances originate from aromatic substances identical or comparable to those in the condiments themselves. For humans, the revelation senses enchanting traversing through moist woodlands merely to discover the fragrance of a condiment repository. But for the fungi, these fragrances are utilitarian impulses to attract arthropods or repulse predators. Their chemistry is endurance, even if it registers to us as pleasure. Mycologists frequently depend on fragrance as component of identification, positioning low, to inhale the concealed signatures of varieties. Each fragrance is a notation in the composition of the woodland, imperceptible, yet unmistakable, a reminder that fungi are biochemists as considerably as recyclers, extracting the atmosphere into perfumes we possess with us long subsequently. Fungi can assimilate and accumulate hydration like absorbents. When precipitation descends, fungi expand rapidly, occasionally duplicating their mass in a singular evening. Their structures are composed of chitin and particular cellular structures that function like minute repositories, absorbing hydration with remarkable productivity. This capacity enables them to reproduce abruptly following tempests, manifesting almost instantaneously in grasslands and woodlands. But dehydration is not merely for the fungus. The assimilated moisture can gradually discharge back into surrounding substrate, generating microenvironments for arthropods, mosses, and seedlings. In this manner, fungi function as animate absorbents, regulating moisture and supporting existence considerably beyond themselves. For gatherers, the hydration-saturated tissue of particular fungi is a recognizable indication of their flexibility. In environments, it is endurance tactic converted into benevolence, precipitation captured, accumulated, and distributed. Each fungus is more than a reproductive structure. It is a container possessing the recollection of precipitation and discharging it gently into the rhythms of the woodland. Fungi might possess the resolution to carbon sequestration. Among the most significant obstacles of our epoch is extracting carbon dioxide from the atmosphere, and fungi might provide component of the resolution. Mycorrhizal fungi particularly establish collaborations with vegetation that amplify carbon accumulation subterranean by channeling carbohydrates from vegetation into profound substrates. Fungi assist securing carbon away for ages, preventing it from returning to the atmosphere. Certain fungi even manufacture substances that resist decomposition, productively sequestering carbon in constant configurations. Researchers are examining how fungal systems could be stimulated to amplify this consequence, potentially converting woodlands and substrates into more potent carbon repositories. Envision climate modification, countered not merely with apparatus, but with animate mechanisms' imperceptible filaments constructing carbon back into the planet. In the quiet function of fungi exists a prospective confederate against the warming of our world, demonstrating that resolutions might currently be beneath our position awaiting patiently to be acknowledged. fungi could assist terraform additional worlds. If humans eventually establish Mars or additional realms, fungi might be among our most reliable companions. Their durability renders them prospects for fragmenting geological material into substrate, manufacturing sustenance, and even recycling refuse in enclosed surroundings. Certain fungi can endure radiation and reduced gravitation, rendering them beneficial for constructing existence support mechanisms in orbital space. Mycelium could even generate construction substance lightweight, resilient, and biodegradable configurations cultivated rather than manufactured. Researchers currently envision fungal biodomes where environments are not constructed but nurtured, expanding like animate construction. This visualization resonates our planet's individual chronicle, when fungi assisted establishing the terrain for vegetation hundreds of millions of seasons previously. They were pioneers previously, and they could be again, transporting their primordial capabilities into extraterrestrial terrains. If humanity eventually disperses beyond our planet, it might not proceed isolated. Fungi might construct the foundations of our novel realms, precisely as they accomplished this one. Fungi are the recyclers, the collaborators, the physicians, the quiet architects of our planet. They function imperceptible, yet their non-existence would be devastating. Every meal, every inhalation, every verdant terrain exists because fungi are present equilibrating the mechanism. To comprehend this is to realize that fungi are not secondary figures in the narrative of existence, are its foundation. Without them, the platform would be vacant, and the performance of existence could never commence. Good night.